know if you remember, but an added benefit of the synthetic division is it allows you to evaluate a polynomial. So if we don't get, let's go take a look at example 3. If we don't get a 0, all right, what we did get out of this, by the way, is if I plug in a 2 to x to the third minus x squared minus 4, I'll get a 4. So it's a quick and easy way to do substitution synthetically. I think that and I found the quiz, XYZ quiz, a little confusing on this problem. I think they're asking you to do it both by plugging it in and also by using synthetic division. Now I'm going to do that on the first one just to kind of prove my point, but I don't see why you'd want to do it twice on the same problem. So I have, there's my x to the 4th, there's my x to the 3rd, there's my x squared, there's my x, and my constant. Okay, so I don't have any missing terms, and I'm just going to do the same old procedure. Try not to make errors. Okay, so this means that p of -1 is equal to -5. Now, I'll go ahead and do it the long way. In fact, I'm going to pause the video. Can't imagine you wanted to watch me do my substitution step. Okay, starting with my calculations. -1 to the 4th power gives me a +1, so I get a 3. -1 to the 3rd power gives me a -1. -1 times -2 gives me a 2. And -1 squared gives me a +1, but the negative will make it negative, and I get a -4 and -5. Okay, so pretty clearly that's 5, that's -5. I'm left with a -5. So either way, I'll get the right answer. I'd prefer to do it that first way. All right, you also get it right after a problem like this. You get a problem that's phrased this way. Use the remainder theorem to find the remainder when p of x is divided into the binomial x minus 1. Hey, they're just asking you to do the same thing a different way. So set up your synthetic division, and p of -1, we already calculated it above, is -5. So a different way, and a rather confusing way if you ask me, to get you to do the same task. Okay, I need to change this problem, and I realized it a little bit late, so I'm going to replace this with x to the 3rd minus 3x squared minus 25x plus 75. All right, it says to solve completely, and what they're implying is that we are just going to use, hand tools, I guess. And the way we tackle this is we start by looking at the rational zero theorem that says that our zeros are going to come from only these numbers. The factors of my leading coefficient, that's 1. That makes sure I'm not working with fractions. That's kind of nice. My factors of 75 are 1, 3 will go into 75 evenly, and 5 will go into 75 evenly, and so will 25. So 75 is a factor, and 25, and there's got to be another factor in there. Let me see, 75 divided by 5, I think, is 13. Yeah, there's our other factor. So these are going to be the only possible zeros of this polynomial. And I'm going to start with middle numbers, and I'm going to start with plus or minus 5, or maybe 13. We'll see. But 5 just seems to be a number that I'm seeing quite a bit in, say, my x term and my final term. So, and we're kind of guessing here. So we start with just, one of our numbers, and we do our synthetic substitution and see if it works out. And sometimes the way it doesn't work out gives us a little more information on how to make it work. So I'll just start my substitution. I get a 2. So 5 is 10. I get a negative 15. 5 times 15, I think, is 75. Negative 75. I'm going to double check that. Okay, so I got pretty lucky, and my first guess worked out. So I can rewrite solve completely. I still have a quadratic to take a look at. So when I'm going to rewrite this as x minus 5, that's the 0 I just took out, times x squared plus 2x minus 15, see if I can factor that quadratic. And I think I can, because if I multiply a positive 5 times a negative 3, I'm going to get a positive 2x. So it looks like x minus 5, x plus 5, and x minus 3. So all my zeros are going to be plus or minus 5 and positive 3. And if they're asking you to do this, they'll be fairly simple problems like this. All right, I'm going to stop this video. See you on the next one.